Hi everyone, this is Sir Philip, and for today, I will be discussing about a topic in my grade 11 statistics and probability class, the mean, the variance, and standard deviation. At the end of this class, hopefully, you can be able to identify the stats on how to solve for the mean, the variance, and the standard deviation. Well, to begin with, as a review, can you still remember what are the different measures of central tendency that we have discussed in your modules or you have read when you were in your grades 8 to 10? Uh, First of all, when you say mean, that is the average. We get the data by identifying the average of the set of data. When we say the median, that is of course the middle value, when your terms is odd divided by 2, add 0.5, you get the middle value. When your terms or when your number of terms is even, you get the sum of the two middlemost value. And when we say mode, of course, that is the most common value. That is the number, that is the term that appears most common in your value that you have. Now, here in this lesson, we will tackle about the variance. And when we say variance, that is the variance combines all the values in your data set to produce a measure of the spread. That's why it is called the measure of dispersion. It is symbolized by S2 in some cases, that is symbolized with a zero, with a head, and standard deviation is the square root of the variance, symbolized by your S. And these are, again, the most commonly used measures of spread. And we know that variance is a measure of how spread out the data is. For example, when you look at your grades in the last semester, when you look at your grades, how far is the highest score from the lowest score? That is actually called the range. So that is when we want to find out how spread our data is. When, for example, sa tinapay, mag-spread ka sang data, mag-spread ka sang margarine or some butter, that is like also how when you solve for the variance or standard deviation. It is calculated as the average square deviation of each number from the mean of your data set. Now, for example, you have the following data set, 3, 5, 7, 10, 10. And data set 2 is 7, 7, 7, 7. What is the mean and the median of the above data set? In the first data set, in 3, 5, 7, 10, 10, the mean is, when we add 3 by 5, the answer is 8 plus 7 is 15 plus 10 is 25 plus 10 is 35. So this figure or this number, when you divide it by 7 or 5 rather, it will give you a mean of 7. And the median here is 7 because when you arrange this is already arranged in the least to greatest, the middle term is 7. In your data set below, the mean is 7 because they're all 7, and you add all of this, that will give you 35. Divided by 5 is 7. And the median is, of course, still 7. Now, why does it matter? We know that the two data sets are not identical, but they have the same value of the mean and they have the same value of your median. Here, the variance shows how they are different. We want to find a way to represent these two data set numerically. So that's why variance is very important. Now, if we conceptualize the spread of a distribution as the extent of which the values in the distribution differ from the mean from each other, then a reasonable measure of spread might be the average deviation or the difference of the values from the mean. So how far is the values from the mean? For example, imo average in the second grading is, let's say, 92. How far is the highest score, which is 96 from 92? How far is the lowest score, which is 85 from 92? And that is how we get to know, or we get to make use of our variance. That is the summation of your x. X here is the score, minus x here is your mean. This is the mean. This is your score. Example, your grade is 90. The average of your grade is 92 over how many are them? the number of the terms that you have. Example, you have 9 subjects, so n there will be represented by 9. So that is how you get for the variance. However, we cannot solve that instantly. We need to make use of a table later. So to continue, although this might seem reasonable, this expression always equals to 0 because the negative deviations about the mean always cancel out the positive deviations about the mean. We could not, or we could just drop the negative signs, which is the same mathematically as taking the absolute value. Take note, for example, when your score is 85 minus 92, the answer will become negative 7. But take note, here you can drop the negative sign. You can drop the negative 7, make it positive. When your score is 90 and your average is 92, 90 minus 92 there is negative 2. You can drop the negative sign and make it positive. The concept of absolute value does not lend itself to the kind of advanced mathematical manipulation necessary for the development of inferential statistical formula. For the case of this problem, you can drop the negative sign, okay? And the average of the square deviations about the mean is called, again, that is the variance. For example, you have the following scores. So kagina ginatag man ni 3, 5, 7, 10, 10. So the average is 7 because 3 plus 7 plus 7 plus 10 plus 10 is 35. Divided by 5, it will give us the mean of 7. How can we get the value of our variance? So in here, we can have our variance in this case. For example, 3 imo score, imong average is 7. So 3 minus 4, it will give you negative 4. 5 minus 7, it will give you negative 2. 7 minus 7, it will give you 0. 10 minus 7, it will give you positive 3. And 10 minus 7, it will give you positive 3. Your negative 4 and negative 2, of course, are negative values. Again, as what I have mentioned earlier, you can drop the negative sign and make it positive. Okay? To find out the square explanation, yaman. Your negative 4 times negative 4 will equal to a positive number. Your negative 2 and negative 2 will also be equal to positive value. Same with positive. Positive 4 and positive 4 is still equal to 16. Negative and negative is also equal to 16. On the third table, we have here the values. So this is negative 4. Inisa sa third table, gina x minus the mean raised to the second power. We get the square root, or we raise the difference to the square root. Example, negative 4 raised to the second power is 16. Negative 2 raised to the second power is 4. 0 is 0. 3 raised to the second power is 9. And 3 raised to the second power is 9. Take note, we don't have a negative answer here. Okay? So adding all of them, we get 38. So this is the continuation. So 38 here divided by 5, it will give you 7.6. So your variance now is equal to 7.6. That is the average, the summation of the difference of your term and the mean score raised to the second power. So that is how easy to solve for the variance. I hope you get my explanation. So the standard deviation is the square root. Another measure of dispersion is, of course, our standard deviation. Our standard deviation is the square root of your variance, symbolized by S earlier. So if the variance is 7.6, then get its square root to get your standard deviation. So if you have your calculator, muni siya tulukon nimo, but the formula inside is the formula of the variance. If you were able to solve for the variance, instantly it will become, the numbers here will become 7.6. So you get the square root of 7.6. It will give you 2.75668,087 and so on. You just round off to 2 decimal places. It will give you 2.76. Therefore, the standard deviation is 2.76. Now, I have here another example, sample 2 data. This is the example of your age from 1 to 90. Then here, the deviation from the mean. How far is the age from the mean? The given mean, for example, mean sang edad is 20. So 1 minus 20 is negative 19. 2 minus 20 is negative 18. 3 minus 20 is negative 17. 4 minus 20 is negative 16. 190 minus 20 is equal to positive 70. Take note that all of the numbers here are negative and only 70 is positive. So what you need to do, raise each answer here by the second power. So negative 19 raised to the second power is 361. Negative 18 raised to the second power is 324. Negative 17 raised to the second power is 289. Negative 16 raised to the second power is 256. 70 raised to the second power is 4,900. So you get the summary. This symbol is the summation. Inidito na ng symbol nila di summation man. Ang sum ng age is 100. Here, the sum of the mean is 6,130. So what you need to do, this is the sum of the squares. This is 6,130. Sum of squares deviations from the mean. So if you want to calculate for the S squared or the variance, what you need to do is you have 6,100 going back, 6,130, am I right? Okay. 6,130 divide it by, I think this should be divided by 5 and not 4. However, my formula kita din n minus 1. So that will become 6,130 divided by n minus 1. N is 5 minus 1 is 4. Another way na siya presenting ha. So that will be 1,532.5 years raised to the second power. So to get your standard deviation, you have square root of 1,532.5, that is 39.15 years. 39.15 years. This is for sample sizes. Itong isa, population sizes naman. Okay? So another example is this. Okay. So if you have clarifications regarding this presentation, you may leave a comment or you may ask me otherwise regarding this presentation about the mean, the standard deviation, and the variance of a set of data. That would be all. Thank you very much for watching.